This is the multiple regression video on an introduction to the topic. This module will cover the most complicated study design having a continuous outcome, namely the case where there are many predictors. When some of the predictors are continuous and some are categorical, we have an analysis of covariance. Most of the things that we'll cover will hold with equal force regardless of the scale of measure of the predictors. And I'll let you know when something only holds true for a special case, such as all the predictors being continuous. Indeed, most of what we'll cover will hold true regardless of the scale of the measurement of the outcome variable as well. Although intermediate cases do exist, multi-predictor models are usually developed to achieve one of three purposes. These purposes are prediction, variable selection, and adjustment. For now, I'll just introduce these three types of application. For prediction application, the primary focus of interest is in the model's prediction. For example, the Apache score gives a predicted probability of surviving an ICU stay. One can easily imagine the information being used to counsel patients and their families, and also to study the pattern of outcomes within an ICU. In particular, asking questions such as whether survival is better or worse than anticipated. So of less interest exactly how these predictions are derived, so long as they're accurate. For variable selection application, the primary research question is which, out of a large group of variables, are the strongest predictors of outcome. For example, which out of a large set of clinical measurements most strongly predicts the rejection of an organ transplant. Although you might have some preconceived notions about which of these predictors might matter the most, you haven't subdivided them into primary versus secondary, and instead will let the data decide. For covariate adjustment application, which we'll sometimes call a critical experiment, you've decided ahead of time which predictor variable or variables are of primary interest and which are of secondary interest, and thus become the covariates. One example is a randomized trial. The intervention group is the primary predictor, and you include the various covariates in the model to increase its overall precision. As another example, in a longitudinal study of predictors of cancer incidence, the level of caffeine consumption might be the primary predictor, and you include various covariates in order to account for the fact that coffee drinkers might differ from others on a number of other variables that are known to be related to cancer risk.